All right, so this is number 82. Title is Trapezoid. And a trapezoid is a quadrilateral with exactly one pair of parallel sides. A quadrilateral with exactly one pair of parallel sides. So this is one possibility for how it would look. Oops, that's a terrible line. That's a trapezoid. The reason it's a trapezoid is because this side is parallel to that side. Even if you extended this forever and extended this forever, they would never hit each other. But if you extended this side, it would eventually hit this side. So these two sides are not parallel. Okay, the sides that are not parallel are called legs. And then the sides that are parallel are called bases. The sides that are parallel are called bases. Now that's kind of strange because, at least on this trapezoid, the bases are not on the bottom. When you hear the word base, it sounds like bottom. But this one is on its side, right? So this is the base, and this is the other base. So we call this one base 1 and this one base 2. So that bothers people a little bit because the base doesn't have to be on the bottom. In this case, the leg is on the bottom. Okay, one thing that's true about trapezoid is there are two pair of consecutive angles that are supplementary. Two pair of consecutive angles that are supplementary. What does supplementary mean again? Yep.
More than 100 degrees. Adds up to more than 100 degrees.
No, it does add up to 180 degrees. Good. So you remember the 180? Supplementary means it's the two angles add up to 180. And the consecutive ones are this one and this one. Those add up to 180. And the reason that's true is because there are two parallel lines here cut by this transversal. And when you have parallel lines cut by a transversal, the consecutive interior angles are supplementary. So this is not new stuff. We had this back when we talked about parallel lines. These are called consecutive interior, so they're supplementary. These are called alternate interior, so they're congruent. Okay, so that's why those are supplementary. And the same thing's happening up here. These two angles add up to 180. So we have two pair of consecutive angles that are supplementary. Okay, then sometimes we find the midpoint of the leg. So I'm going to draw the midpoint of the leg and put a tick mark here and a tick mark there to tell you it's exactly in the middle. And then this midpoint also. And then when you connect that, when you connect those two midpoints, you get a line that's called the median. Okay, so a median is a line segment that connects the midpoints of the legs. A line segment that connects the midpoints of the legs. And it turns out that if you want to find the length of the median, you can take base 2 plus base 1 divided by 2. So over here, you could measure this, see how many centimeters it is, measure this and see how many centimeters it is, and then add those up and divide by 2, and that would tell you how long the median was. You wouldn't have to measure the middle one, the median. You could just measure these and add them up and divide by 2. Okay, and then last but not least, to find the area of a trapezoid. So area, right, is counting how many squares would fit inside. So to find the area, you take this median and you multiply it by the height of the trapezoid. So that's it for the note card. Get a sheet of graph paper today. You can just do your work on this graph paper if you want. Sorry, one more. Send all those back. So for this, the plots we're going to point are fairly large, so use the entire front side for the x and the y-axis. So the y-axis should go in the middle this way, and the x-axis should go in the middle here. So the origin should be way down here in the center, so we got plenty of space to plot all our points. So title of this paper is Trapezoids. And we're working on number 6 right now. We got some points to graph. Here's the points that we're going to graph. These points are called J and K. I'm not joking. You have to graph these. right, so we got our x-axis and our y-axis. Y-axis. X-axis. All right, so there we got this four-sided figure, so it's a quadrilateral. Is it a trapezoid? Certainly looks like it, right? Because it looks like this side is parallel to this side. How could we investigate just to be 100% factually true or factually certain that these sides were parallel? So what formula could we use to figure out if these are parallel? Yeah. Slope formula, right? Because if two lines have the same slant, if two lines have the same slope, then they're parallel. Okay, so I'm going to find the slope between L and K. So for slope, you do y minus y, so -6 minus -6. And then x minus x, so -6 minus -12. So -6 minus -6 is 0. -6 minus -12 is 6. And 0 divided by 6 is 0. That should not surprise us, right? Because this line looks like it's pretty flat. So it doesn't have any slant to it. So the slope is 0. All right, now I'm going to find the slope of JM. So that's -18 minus -18. And 0 minus -18. So that comes out to 0 over 18. And 0 divided by 18 is 0, which again should not surprise you, because that line looks like it's flat. So these two slopes are equal. So that means that JK is parallel to, LK is parallel to JM. So that means we do have a pair of parallel sides. So that means it's a trapezoid. So yes, quadrilateral. When you name a quadrilateral, you go into circular. So you go JKLM. Quadrilateral JKLM is a trapezoid. Okay, then number 8. Oh, sorry, before I get on to number 8. Parallel lines have the same slope. What happens, how do you know if two lines are perpendicular? Yeah. So they have to be opposite reciprocal slopes to be perpendicular. So for example, if one of the slopes was 7 over 3, the other slope would need to be negative 3/7, right? If these were the slopes, then they would hit at a 90-degree angle. But then on this problem, since these slopes are the same, that means they are parallel. Okay, so now we're ready for number 8. Number 8 says find the length of each side of the trapezoid. So for LK, that's easy. I'm just going to count. But for JK, what am I going to do to find the length of that side? Yeah. Distance formula. Good. So that's negative 18 minus negative 6. And negative 18 minus negative 12. So it's a lot like the slope formula. You still subtract the y's and subtract the x's. You just square them and add them in this case. See, 144, 150, 180. So now we got the square root of 180. That'll split up into 36 and 5. So the final answer is 6 root 5. We've been doing the distance formula a bunch. That's why I kind of did that really quickly. Everybody doing okay? Okay, so a trapezoid is a four-sided figure, a quadrilateral, that has one pair of parallel sides. If it had two pair of parallel sides, then it would be called a parallelogram. But if it just has one pair, it's called a trapezoid.